Welcome to the 19th video in our series about Unix tools. This video continues the discussion of grep and regular expressions started in the previous 18th video. In the 18th video, the last thing we did was a hex dump of the ex4.py file to identify that the tab character had been used in this def statement. We know this because number 9 is a tab character. Here's another one which is used for the indentation for this print hi mom statement. Here's another one that's used for the indentation of the return statement. And finally, there's one more right here for the indentation of the sys exit. So we were going to take a look at our grep statement, and we can use grep to find our grep statement. Actually, we can grep for grep in our video 18, and you can see those are the greps. So this was the grep we were going to try. Let's cut and paste it and use it on ex4.py and see what we get. And you can see it did show the def main. And as we did in the previous video, we can give an in to show it's on line 7. And to identify line 7, we can use the cat -in, and we'll use the -t option if we want to see tabs, or we can use -a. -a shows tabs and new lines and any other control characters, using hat for the control characters and tabs and a $sign for the new line. This allows you to see if you have spaces at the end of the lines, which is a no-no in programming. So let's do the cat -in -a ex4.py, and you'll see, aha, there it is. The $signs mark the end of line, and these hat eyes mark the tabs, and there are no other control characters. So our grep did work. I told you that this wasn't the perfect grep statement, so let's see why. Let's copy our ex4.py to ex5.py, and then we'll use nano to modify that, and we'll add another function, and we'll call this fancy one. And we'll put a doc string in there, and finally we'll just print the name. So I said this was a function, but you see we return nothing, so it's technically a procedure. The fancy name that includes both functions and procedures is called subroutine. These are programming terms that I hope you learn while you're studying computer science. But here it is, fancy one. And then somewhere we should include a call to fancy one. What should this program do when we run it? It should print hi mom fancy one and then exit. So let's save it as ex5. We'll do our ls long so we can see the permissions to make sure it has read, write, and execute. It does, because when we copied the file, it also copied the permissions. So we can do a // to say, in this directory, run ex5.py, so we don't get some other ex5 that might be on the path. And it does just what I said it would. Hi mom and fancy one. We know, if we scroll back, that there are two subroutines. And we'll do our cat minus n minus a of ex5.py, and we'll see there are two of these top level defs, one for the fancy one and one for I main. Let's try our grep again. We're hoping that we'll see two matches, but we only got one match, and this is why I said our grep pattern wasn't perfect. What's the problem? It matched the def and the tab and the first letter, which was F or M, and then it went and it said any letter or underscore, but you see I have a digit. Wow, there it is. I can finally mark it. On line 7, the function name has a digit. You can't start a function with a digit, but you can start a function with an underscore, and you can have a digit anywhere else in the function name. So we've got two problems. The first pattern is missing the underscore character, and the second part of the pattern here that I've highlighted is missing digits. So we know how to add the underscore, and we can add some digits here, and we can try again. We still only got the def main. We didn't get the fancy one, and so we have to ask ourselves, why is this not working? And the way to debug a regular expression is to just check different parts of it. Okay, so let's do a grep minus n and search for this part of the pattern. Just that. Okay. Any letter or digit or underscore and everything with def main, but you see it's still not there. And if we think about it, we have to look at this and say, wait a minute, ex4, we're grepping the wrong file. So let's grep ex5, and if we grep the correct file, both of the top level function definitions were found. But we haven't really tested any underscores. So let's do that really quickly. We've got about 2 minutes left in our video. So to make this, or to prove that we can have some underscores, let's put some underscores in here. Fancy one, and we need to update the call. And then we could, this is a terrible name for main, but just to show you, you can start with an underscore, or we can have an underscore in the middle. So let's run it to make sure we didn't break the Python code. It runs. Did we break the grep? This time with ex5. No, the grep worked. So you can see that this grep is working well. This pattern. One last thing I want to point out in today's video is I've wrapped the pattern with these single quote characters. Why did I do that? I did that because I don't want the shell to look at this star and say, oh, you want to do globbing. By wrapping it in single quotes, double quotes won't work, but single quotes tells the shell, and remember we're always running in this shell with this $prompt. The shell is a REPL, read, execute, print, loop. If we wrap it in single quotes, that tells the shell, do not do glob expansion. Leave it alone. And that means that this part our pattern, gets sent to grep, and grep will decide what to do with this pattern instead of the shell. Okay, we've hit our time limit again. I want to thank you for listening, and I hope you'll come back for the next video.